if we use the right letters, because they're using D and K and they switch which one means where. So if you look through the text part of it, just be careful because they switch what letters there are, and I've switched them back because I think it's easier to understand. Because what we're looking at here is we're trying to figure out what value of C would make this be a perfect square trinomial. Meaning, if I factored it, it would be x plus 2 times x plus 2, or x minus 3 times x minus 3. So we're trying to figure out what that C value will need to be. So we can actually use our B values for this. So what we're going to look at is the expression that gets used, which I'm going to mark this so I can go back to my notes, to help figure this out. Okay, gotta get back. Getting back to our notes for today. Is right there. Okay, so when we have our x squared term, so our a term and our b term, and our a is going to be 1, what we can do to figure out what that number needs to be in order to make a perfect square, try and make it so you guys don't have to zoom in like that, is we're going to take our b value and divide it by 2. That's part 1. And then square it. This is going to give us the C term that completes the square. And I promise I will show you exactly what this looks like. If you like doing it with the proper letters, it makes way more sense than with their chaotic K and D. Especially when they then switch which K and D stand for halfway through the problems. Super fun. So just make sure we're being very careful and paying attention to the letters in the book because they switch around what they do. Since X is used for a standard thing, they switch between K and D frequently, and where they put it changes what it stands for. That's why I'm using B and C right here. So what we're going to do is we're going to figure out what C needs to be for this first one to make it be a perfect square. So that's what this one's asking us to do. So we're going to use that little formula that we have up there. Our C is going to be where we take our B term here, -8. We're going to divide it by 2 and then square it. So I'm going to simplify this in pieces. What's up? Okay, just checking. What is inside my parentheses going to simplify down to? -4. When I square -4, what do we get? 16. So if I rewrite this as x squared minus 8x plus 16, this is a perfect square. Factor it so we can see why. So I want you guys to factor this. X and box, factor by grouping, whatever you got. Factor this guy. What do we get as our factored form here? X minus 4, x minus 4. Also known as x minus 4 squared. That's why this is called a perfect square trinomial. Okay? This thing factors exactly down to x minus 4 squared. And in fact, we don't even have to do all that factoring work to find that answer because the piece inside here is always going to be this piece right here. So b divided by 2 gives us our factor. B divided by 2 squared gives us our c. We are going to be using this when we are solving stuff. We will use this again later in the year, completing the square. So this is one of those things we're going to hit pretty hard today. Questions on this first one? Because it's been a hot minute since we saw it. Because you have seen it, but it's been a minute. And I think you saw this once. And you saw this like once. Because we did this a different way last year in Algebra 2. This was our vertex, the axis of symmetry gives you the exact same answer for our factored form. Okay? It's doing the exact same thing as finding our axis of symmetry and putting it in as our vertex. You did this in Algebra 2, finding vertex form of a quadratic. That's when you would have done this. Because usually we didn't do the squared part. We just did it there, and then we multiplied it out. We did all kinds of other things. This is just more efficient and faster. Okay, so we're going to do the right-hand one. It is going to be less pretty, but it's okay. We can do less pretty. We can do ugly things. So our C we're going to get from doing the little formula up at the top. We're going to take our C and find it by taking the B, which is our 9, dividing it by 2, and then squaring. You can leave it as a fraction, or you can put it as a decimal. I genuinely do not care. Whatever you like better. As long as you know how to square a decimal. I don't care. What is 9 over 2 squared? Yes. So 16.25 if you're switching to decimals. If you do this as 4.5 squared. I think that's right. That sounds right. Yeah, 16.25. Or if you do it as a fraction, it's going to be 9 squared, which is 81. Over 2 squared, which is 4. And this should be, I'm 95% sure that you are actually right. Was there 16.25? Oh, no, not 16. 20.25. You can do it either way. I genuinely do not care if you do decimals or if you do fractions. I tend to write them as fractions because 9 squared and 2 squared are a little bit easier to do in my head. And we don't need decimal answers. But if you are a decimal person, rock on. So I'm going to write this into my perfect square form. So what we're doing here is we're taking our x squared plus 9x plus, and I'm going to use my fractions because I like them better, but you can do whichever one you want. If I have my C being 81 over 4, or 20.25, this is a perfect square. We designed it to be so. We picked it, we made it that way. Our factored form is going to be x plus this guy. It's always the piece pre-squaring. So you could either do it as your 4.5 or as your 9 over 2. They are identical. They are equivalent expressions. They mean the same thing. 9 over 2 is our factor squared. So the 9 over 2 is this piece. Whatever our b divided by 2 is your factor. b over 2 squared is what your c will be. Questions on these two? Because the next ones come at it from a different angle. Okay. So more often than not when we're completing the square, we're picking C. Like that is the thing we get to make. They're having us practice it in a way that we don't use for anything, but we're going to practice it anyway because choices. So now they're saying what would D, which is really our B value, but again, they use weird letters because reasons. So we're going to figure out what the value of D needs to be to make this be a perfect square. So we're going to use that same kind of expression that we did to find our C. Our B value, it was our B value divided by 2 squared that made our C value, right? That's the formula we were using. Well, now I have C, but I don't have B. So, okay, so on this first one, my x squared plus something x plus 36, which you can put it as D or you could switch it to B because we're more comfortable with it. I don't care. I don't like that they kept changing letters. So 36 is our C value. I know C. We can find the B we would need by substituting it in. So we're going to take our 36 and set it equal to our B over 2 squared. You can put B or you can switch it to D as the equation says. The equation says D, our formula says B. They're the same, please. Everyone see how I set this up? Okay. What can I do now to figure out what B is going to be? Square root both sides. Boop, boop, boop. Boop, boop, boop. When we take the square root of a perfect square, what do we need to make sure we remember? Plus or minus. So my right-hand side is just going to be B over 2. My left-hand side, plus or minus 6. But I don't want to have B over 2 equals. I just want what B equals. Times it by 2. Okay. So that center term is going to equal either positive or negative 12. We're not going to put this into our factored form because it is going to give us 2 different ones on this. We could if we wanted to, but what they're wanting us to spot is to start trying to notice the patterns here. If this middle term is either 12 or negative 12, then this is a perfect square trinomial. So B is D in this particular case because they like to change variables on me. So the answer for this would be that D is plus or minus 12. Okay, so again, they jump around and move the letters on us because they like to make choices and make things harder than they need to. So the answer is that D is plus or minus 12, but we found it out because D is our B variable. Questions on this one? Again, this is not a way we typically do complete the square when we actually are using it for things. We will pick C values, absolutely, to find perfect squares, but we don't typically do it this way. It's just kind of a mental exercise for us. But they like to throw those at us sometimes just to mess with our heads. So let's do the right-hand one, and we're going to do it the exact same way. It's just got a fraction in it. So we're going to find what number D needs to be a perfect square trinomial. So we're going to find that using our little expression up there. I know my C term. My C is 49 fourths. So we're going to set this up as 49 fourths equals B over 2 squared. Using that expression at the top that we used to help figure out what our C would need to be. So then what are we going to do? Square root both sides. So my left-hand side is going to become 7 over 2 plus or minus 7 over 2. There we go. Because we are square rooting a perfect square. I don't know what sign it's going to be. When we square root a perfect square, we have to put the plus or minus. because it could be either one. Need my black pen back. Thank you. So b over 2. So what is our b going to be? Plus or minus 7. So if that center term is either 7x plus 49 over 4 or negative 7x plus 49 over 4, it's a perfect square. So if d is plus or minus 7, and again, just make sure at the end of the problem, if we switched our variable, because I switched it to b because it's the b term in the standard form, which is a thing we're familiar with, and I like to use things we're familiar with, switch it back at the end, and we are all 100% perfectly good. If we leave it as a b, I'm not mad at it. It's fine, you're still doing the right thing. It's just the name. It's just that we called him Bob instead of calling him Dan. I like it if we use the right names, but in the grand scheme, not that big of a deal for numbers. Those names are important. Okay, so now we're probably going, why the heck do we have to do this? Holy cow, is it overcomplicated? There will be times when we are solving and we are asked to solve by completing the square. Because if we look at this and we tried to factor it, it looks like we could, but we can't. Because we need something that multiplies to be 7 and adds to be 6. And there's not a pair of numbers that multiplies to be positive 7 and adds to be positive 6. If one of those was negative, we'd be fine, but we're not there. So our options are quadratic formula or completing the square. And it's going to give us the same answer either way. Once we get the hang of completing the square, it is actually fast. But we're going to go through them slow because they're awkward. So I'm going to write kind of steps on the right-hand side. We're solving here. This is going to be the one and only time I don't need it to equal 0. So what we're going to do is we are going to isolate our variables on the left-hand side. And I'm going to move constants over to the right. So my first step is going to be to isolate variables. I want to get it to the point where I have just an x squared. And just my x. So I need an a of 1 and only x is on the left-hand side. So I'm going to start by subtracting 7 from both sides. So that's going to give me x squared plus 6x. I'm going to leave a gap. Then I'm going to put my equals negative 7. I know we don't know why yet, but questions on that step. Okay. So now we're going to think through those first two that we did, the very, very first two. What would I need to add here, ignoring this side, to make that be a perfect square trinomial? B over 2, then square. 9. 6 over 2, which is 3. 3 squared gives us 9. So if I add 9 there, that's a perfect square trinomial. And as long as I do it to both sides of my equation, I can do whatever the heck I want. So what I'm going to do is I'm going to add 9. I already have a plus there. So I'm going to add 9 to the left side. And as long as I add that same 9 on the right-hand side, I can do whatever the heck I want. So I isolate my variables, and then we complete the square. And I know at this point we're still going, why? Have faith in me, I promise. So now we're going to factor the left-hand side. This piece. We just added our 9 here. So factor this guy. The left-hand side. We're going to get x plus 3 times x plus 3, which is also known as x plus 3 squared. And that's going to equal negative 7 plus 9, which is 2. Questions on either of those two steps? Now we can solve this with square roots instead of needing to shove the whole thing through that quadratic formula and wind up with some really, really big numbers. So, what can I do to solve this? Square root both sides. I have something being squared. So let's unsquare it. I'm going to take the square root of both sides. And that's going to give me, those two pieces cancel out, leaving me with just x plus 3 equals, super careful, square root of 2. But what else do we need to have here? I square rooted a perfect square, so we need our plus or minus. No, I square rooted a perfect square. When I have this thing that's been squared, I have no idea if this piece was negative or positive because it was squared. Whenever, we're always going to toss it over with our answer because if we put it here, we're going to have to do a whole lot of distribution. And like it's a weird thing. You can, if it helps your brain, you can do it as, I'll write it over here, x plus 3, like this. But then we're going to have to split it here, and it's going to be a whole lot of weird. So if we think about how we did it when we did this like yesterday stuff, plus or minus, if we square something that's been, or if we square root something that's been squared, put plus or minus with your answer. Because this piece either equals the positive version of this, or this piece equals the negative version of this. Okay? So I was like, you can do it that way, but it's a lot harder if you put the plus and minus with your variable. Because we only have one step left here for this one. What do I need to do to get my x all by itself? Subtract 3 from both sides.
And do we keep 2 under that?
Yes. So we're going to finish this by solving it. Subtract 3 from both sides. So my answer is going to be x equals negative 3 plus or minus the square root of 2. And this is the best order to put it in. If you flip-flop them, make sure the plus or minus stays in front of the square root of 2 and that it is very, very, very clear that the minus 3 is not inside your radical. So I'm not mad if we write it this way, where we have our x equals plus or minus square root of 2 minus 3. But that needs to be crystal clear that these things are separate. If this oozes over, you've changed your answer entirely to plus or minus I, technically. So you've taken us from a real answer down to an imaginary. So be really, really careful not to extend this over. It is best practice to put your whole numbers in front of your radicals and have radicals be the end. What's up? We subtracted 3 from both sides, from right here. So I subtracted 3 from both sides, and that gave me a negative 3 over here. Okay? Questions on this one? Okay, cool. I'm just trying to keep eyes on time. Because we're going to do another one, because I've said something a couple of times for us to keep track of, but we've never had to do it. So our next one is going to look like this. So now I have an A value in here. I've mentioned it a couple of times, but we haven't talked about what to do with it. So we're going to follow the same steps. We are going to isolate our variables. So I need to make it so I have just x squared and my whatever x. Just those two pieces. What's up?
And we're only isolating when we're trying to actually solve the equation, not just factor it out.
We're only isolating like that when we're completing the square. Like
Okay.
if I specifically say completing the square, that's when we do this. Every other time it's going to be equal to 0. So the first thing I want to do is get my x squared and my x all by themselves. So I'm going to start by just adding 5. So I've got my 2x squared plus 8x equals 5. Add 5 to both sides. And then we really haven't talked about what to do with A values. I would really rather it wasn't there. It's super gross. What could I do with the 2? Factor it out. We're not taking a GCF. Don't try and pull an X. We're just taking that A out. So I'm going to make this be 2 times x squared plus 4x. Still equals 5. Which is better, because now I could just look at this guy and go from here and rock out with him. But I'd rather this wasn't here at all. I'd rather it's not have parentheses. What can I do to make that 2 go away from the left-hand side? Divide. Divide every side by 2. So I'm going to divide the left side by 2, which is going to make it cancel out. And the right side is going to be gross, but fine. So I'm going to have my x squared plus 4x. On this one, I'm going to leave my gap. And it's going to equal 5 halves. So it's really unpleasant. But I promise these values are going to be easier than like quadratic formula. You'll get big numbers with less radicals. Where'd I lose you?
We're still trying to get our B, right? We're trying to get our B first and then
So I wanted my x squared all the way by itself first.
okay.
So I want to have an a of 1. Then it works exactly how we just did.
So if you kept the 2x squared in there, would it still work or would it just be more work?
It would be more work because then I'd have to take my middle and divide by 2 times a and then square it, and then it's a whole rigmarole.
Okay.
So it makes this overcomplicated process easier if we just have an x squared. So now we're going to look and see what would need to be here in order to make this be a perfect square trinomial. So ignoring the 5 over 2 entirely. He's not involved in the process. He's in the way and just ugly. This is where we take our b over 2 and then square it. So 4 divided by 2 is 2. 2 squared gives us 4. So we're using that, I'm just going to write it over here, our b over 2 squared. So our c term needs to be our 4 over 2 squared, which you guys figured out is 4. Whatever I do to one side, I have to do to the other in order to keep my equations the same. So I pick the 4 and then add it to both sides. It is something we pick. Now we're ready to put this as its factored form, in its completed square form. So factor your left-hand side. What is our factored form on this side? X plus 2 times x plus 2, also known as x plus 2 squared. And it's going to equal what? 13 halves. 5 halves plus 4, but let's simplify it. 13 halves. We can leave things as improper fractions. Totally fine. Still trying to solve this. What do we do next? Square root both sides.
Isn't it like some add and then multiply when you're doing the...
So looking at our adding up the fractions, if we have 5 halves, I want to get it to have a common denominator so we can add them. So 4 in terms of halves is really 8 halves, right? 8 plus 5.
I
It's
just
13.
did it
Yeah.
2 times 4 plus...
2 times 4 plus 5. It's the same thing. Yeah. Okay. So now my square root and my square canceled out. Boop, boop. So we're going to be left with our x plus 2 equals plus or minus square root of 13 over 2. Neither one of those is square rootable. They are unpleasant. They are unfriendly. We're going to leave them like that. What's up?
I don't want to put the 2 on the other side.
We will. We're not done yet. Because what do we need to do next, Nate? Subtract the 2. Yeah, because we want it to be an x equals, not x plus 2 equals. So I'm going to subtract 2 from both sides, and we're going to wind up with x equals. And I'm going to put it as negative 2 plus or minus square root of 13 over 2. And at this time, I'm not going to worry about rationalization right now. We'll get into that again later, but this is enough to throw on our heads all at one point. Okay, so we can leave them as improper radicals right now. Questions on this one? What's up, Nate?
How'd you get 8 over 2?
The 8 over 2 from here, that was me looking at the adding of the fractions, and I just put it as multiplying. That's not even where we are. Come on. Thank you. I just made this to a common denominator. It was I multiplied the 4 by 2, so 8 over 2 is the same thing as 4. And we did that so we could add the fractions together to get our 13 over 2. Okay? Good question. We have 10 minutes? Cool. Let's talk about 14 from the homework. Because that is one that we got interrupted when we went through the one in class together, when we had the Student Leadership Council announcement, and this tends to be one that we get stuck on anyway, so let's talk through 14, which I don't have up here, but I've got the book. So this is homework 2.2, number 14. I want us to work through one like this. The one we did together in class is actually number 13, the one above it, glucose solution. And so we've seen a problem like this before, but it was the one we got interrupted on. And they love to throw these kinds of problems at us. So we will see more of these kinds of problems. I think 2 out of the last 4 finals have had a question like this on it. So we will see more and more of these. Okay, so I want us to practice it. So the problem reads, this is the preparing eye drops problem. It's a pharmacist is to prepare 15 milliliters of eye drops for a glaucoma patient. The eye drop solution has to have 2% of the active ingredient. But the pharmacist only has a 10% solution and a 1% solution. She wants to know what she needs to do to mix them, how much of each, in order to make the right prescription. This is a thing that actually happens in pharmaceutical medication. They're not given every percentage. The Nora apothecary does this. So this is a compounding pharmacy that will do this and actually do these kinds of calculations. So the question is asking how much of each type of solution. So we have 2 types of solutions. This means we're going to have 2 variables. I typically use X and Y. I genuinely do not care what variables you use. Use your own initials, X and Y, happy face and heart. I don't care. It's a variable. It's literally a placeholder. Just tell me what you mean by them. So I'm going to put my X, and we're measuring how much of the solution. So it's going to be milliliters of, and I'll call this one my 10% solution. And we're going to do Y as the milliliters of the 1% solution. That's the 2 types of solutions. We're asked how much. That's a volume. My unit is milliliters. So when in doubt, give me your variables and give me what they are. That's the start. How can we build equations here? Let's start with we need a total of 15 milliliters of solution. Gorge. So our first equation is going to be this however many milliliters of the 10% solution combined with however many milliliters of the 1% solution needs to total up to 15 milliliters. So this is all milliliters. That one's usually not our sticking point. Usually we can find that one. The next one is where we get lost. So we're looking at the active ingredient. So this is our total number of milliliters. Our next piece we're going to look at is our active ingredient. We need to wind up with a solution that has 2% active ingredient. What's our instinct on this one?
0.10x plus 0.01x equals
Yeah. Gorge.
the active.
Gorge. All right, so I'm going to talk it through. So we're taking our 10% of our X. So we're going to have our 10% solution, 0.1, 0.1% of some number of milliliters, right? We don't know how many milliliters yet, but 10% of X is made up of that active solution, the active ingredient. And we're going to be combining that together, so we're going to be adding it to the 1% of Y. 0.01 of Y. And we need that to equal 2% of our solution. So how are we going to put that? 0.2, and this is the part that most people lose, times 15. Oh, that's 20, yeah, 0.02. Thank you. Totally, was just making sure we were paying attention, 100%.
So why are we multiplying 15?
I'm going to talk it through in a second. Because what this is percent of milliliters plus percent of milliliters needs to equal percent of milliliters. So it's the same unit. These were all milliliters, milliliters, milliliters. All have the same unit. Sometimes we'll do it where it's money, money, money. This is percent milliliters, percent milliliters, percent milliliters. They all need to match. Okay? Usually, we get that first one, no problem. And on the second one, we forget that 15. Because we're so used to the Algebra 2 version where we only use each data point once. Where we'd cross it out in the paragraph. Because we don't use it anymore. Okay, so just be really, really careful of this. Now we are solving however we'd like to do so. You can do this as a substitution, where I make my top equation either equal x or equal y, and substitute it into the bottom one. You could do this as an elimination. If you're going to do it that way, I recommend multiplying the bottom one to get rid of some of those decimals. You could multiply it by negative 10 in order to make your x's cancel out, and work it that way. Okay, so we can solve this in quite a number of different ways. The trickiest part is the writing of the equation. Okay, does everyone see where all those pieces come from? Okay, just because, again, that is a very, very common one we get stuck on, and we're going to see them again. Okay, so I wanted to make sure we got a chance to walk through one pretty slowly. So substitute this in. We have 4 minutes left. Try it. Do the thing. Okay? Give it a shot. So I know technically 2-2 is due today, but if you want to turn it in tomorrow because we're still working on this because we got stuck on it, that's okay with me. Or you're welcome to drop it by later today. That is also fine with me. I don't really care. I always give you guys a day of grace on this anyway, so when it says due Wednesday, there's not any penalty if you turn it in on Thursday. What's up?
Can we multiply by 100 to get rid of all the
Absolutely fine.
Okay, it's 100, not 10, right?
Correct. It would be 100 to get rid of all the decimals. And if we're wanting to eliminate, you might try negative 100 because that'll make your y's have the opposite sign. Otherwise, you're subtracting. Mhm.
X plus y by whatever we can do.
So if you're wanting to do this elimination and get rid of all the decimals, our top one's not going to change. Plus y equals 15. And if I multiply absolutely every piece of this one by negative 100, absolutely every piece, I'm going to have negative 10x minus 1y equals Negative 30? Yeah. Negative 30. The reason we picked that negative 100 was to get our y's to eliminate out. When we add these together, we're going to wind up with negative 9x, 0 y's, 1 y plus negative 1 y, which my mouse is in the way. I don't know why that is. Touched everything. Still didn't move. Equals negative 15. So it's gross, but surprisingly less gross. What's up? Since this is multiplication, 0.2 times 15 times negative 100, it's only 1. If it was 0.2 plus 15, yes, we would need to distribute like we did over here. But since they're all multiplication, it's just times. So what is our x going to be here? How many milliliters of 10% solution do we need? 15 over 9. Simplify it. 15 over 9. 5/3. That makes it a little bit easier. Because if I know that x is 5/3, what's my y going to be? How do we find y? Substitute it back in. I know we're going to have 5/3 plus something equals 15. What is our y going to be? Y is going to be 40 thirds. Okay? So we are right to the end of homework 14. So there's our x and our y. What's up?
Can you and Simone both do the process to come during the
Okay, I read you passes.